name is Tanja Bagar. I'm coming from Slovenia, and I am a part of an institute called ICANNA. That is an international institute located in Slovenia, but has been established in the collaboration between Slovenia, Austria, and Germany. And today I'm gonna present a topic that I find very interesting, and that is the molecules cannabinoids, the ones that come from the famous cannabis plant. Today, the focus of the talk will be the cannabidiol, the CBD, and its potential uses in cosmetics. So if we start off with the plant itself, the plant has kind of gotten a bad reputation throughout the last several decades because it was linked to, due to the prohibitionistic movement, it was linked very strongly to the use of heavy drugs, criminal, and etc. And that is why it was kind of called the devil's weed, because apparently it leads the users into later use of heavy drugs, which has now been already scientifically completely disproven. We know today that it's definitely not an entry drug. Maybe rather, we will see at the end of the topic, maybe rather it could be considered an exit drug due to the regulation it does on the reward centers in the brain. Now, in the last few years, the cannabis plant has also gotten the other side of the reputation, namely that it can heal just about anything. There are many reports and anecdotes on the internet of cannabis oil, cannabis edibles, cannabis, all kinds of products healing everything from cancer to multiple sclerosis to anything, you name it, you can find stories about it on the internet. So on the other hand, with the patients, it has kind of gotten the reputation that no matter what's wrong with you, you just use cannabis in really high doses and you'll be fine. You can just get cured. And the truth, of course, is neither. Neither is it a devil's plant, nor is it an angel's plant that heals every ailment in the world. The truth is somewhere in between. And luckily, we have a lot of data on these molecules, cannabinoids. These are one of the molecules that are best studied out in the plant world. And in scientific literature and databases, we have over 100,000 scientific publications on the way and the mechanisms of how these molecules interact with our body. So we have a huge base of evidence of what we can do, what we can expect, what these molecules are capable of, and versus, of course, what they are not capable of doing. So today we can slowly start to talk about these molecules and this cannabis plant from the side effects, not anymore myths and kind of misconceptions that the history has brought us, but we can start talking about really solid scientific facts. And this is what we will be doing in this today's talk. To try and understand what cannabinoids actually do and how they interact with our bodies, we will dive a little into the biochemistry of our body. So from the basic conception, our bodies are composed of several organic systems in our bodies. Let's say the nervous system, the cardiovascular system, the muscular system. We have quite a number of different organs that have very specific functions in our bodies. And if we would zoom in to the individual cells in these organs, we would see that, for example, a nerve cell is very different under a microscope than, for example, an ovarian cell or a muscle cell. So under a microscope, these cells look very different. If we take a look, for example, at how immune cells look versus how muscle cells look, they look very much alike. Look very, very different. And the reasons why their morphology or the way they look is very different because they perform very specific functions. And for example, if we take a look at a single blood cell, once again, they look very differently. But no matter what kind of specific functions these cells have and how different they appear under a microscope, all of our cells have very similar basic biochemical functions. And this is what a typical human cell would look. one of the specific things, if we imagine that our body is composed out of, it was calculated that we have about 36 trillion cells in our body. And if all of these cells, all of these trillions of cells want to function as a whole unit, as one body, the most important function that they have to have is how these individual cells talk to each other, how they communicate. And luckily, they're much better at communicating the cells between each other than we are as a society. And we actually know that cells are very talkative. They don't, of course, send the messages via WhatsApp or other applications, but they produce a number of chemical signals with which they communicate with each other. And the reason why I'm explaining this, so we have a lot of signaling. So, for example, hormones, neurotransmitters, dopamine, serotonin, these are all in their basic functions signaling molecules that help one cell in the body talk to another cell in the body, or, for example, helps the gut communicate with the brain that we're full or that we need food or what's happening in our body. And we call them signaling molecules. And the reason why I'm explaining this is because the cannabinoids, in their very basic function in our body, function as signaling molecules. They're also one of the molecules that cells produce to be able to communicate each other and send these messages one to another. And now if we imagine that this spherical thing is one of our cells, then these little things that are protruding out of them are receptors. Because if a cell wants to be capable of receiving a message from the signaling molecule, let's say from a neighboring cell, it has to have a receptor very specific for this molecule to be able to hear this message. For example, if a cell wants to be able to, a nerve cell wants to be able to respond to the message of a serotonin, it needs to have a receptor specific for this molecule. And this is how we imagine them. We imagine them. So part of the receptor is always on the outside of the cell, sensing what's going on, sensing if we have a specific type of chemical message. And the other part of the receptor is on the inside of the cell, telling this cell what's happening on the outside. This is similar as we human beings and other beings have eyes, ears, and other sensory perceptions that help us determine what's happening in the environment. This is how, in the same mode of action, the cells have receptors. And in our bodies, cells have very diverse range of receptors. So we have receptors, for example, even for temperature. We have receptors for pH value. We have receptors for calcium, natrium, all kinds of receptors. And one of the type of receptors we also have are very specific to cannabinoids. So we have receptors that are called CB1 and CB2 type receptors, and these are specific for cannabinoid molecules. So CB1 would be, for example, a receptor type that binds THC. So this is the cannabinoid we know from the plant that causes the psychoactive properties. And the reason that THC causes these psychoactive effects is because these CB1 receptors are found in very specific locations in the brain that regulate our memory, that regulate our appetite, that regulate our perception in a room. And this is why when these receptors are activated by THC, these areas of our brain are differently activated and they produce something that we perceive as a feeling of a high. And these CB1 receptors are found predominantly in the central nervous system, meaning the brain and the central nervous system, whereas the CB2 receptors are found more equally distributed throughout the body. And if we would look for the place in our body where we have the highest concentration of the CB2 receptors, it would be on the immune cells. Then today we know that we also have other receptors that are activated by these molecules. Namely, we also now know that there is a CB3 receptor. We also know that some other group of receptors are activated by cannabinoids. And the interesting thing is that these receptors were found when the scientists were trying to figure out how THC actually works, why we get high from using it. And when they found that we have these cannabinoid receptors, it was very interesting to see that we have very, very many of these receptors. So there are brain regions that we have that have so many of these cannabinoid receptors, much more than of any other receptor type. And this is, we know that our cells and our bodies are very highly optimized. So it was very not logical that we would produce so many cannabinoid receptors when majority of people are never exposed to cannabis. And then the scientists started thinking that maybe these cannabinoid receptors are not here in case we ever encounter cannabis, but maybe these receptors are here because our bodies themselves produce molecules that bind to these receptors, and these plant molecules happen to bind to the same receptor. And then many decades have passed before this hypothesis was actually proven or disproven. And of course, it was found to be very true. So our bodies produce molecules that are very similar to THC in their function, and also molecules that are very similar to CBD, and we call them endocannabinoids. And endocannabinoids, together with these receptors, are called a part of the endocannabinoid system. And today we know from many studies that have already been done that this endocannabinoid system in our body is very crucial for maintaining homeostasis. So if we imagine that our cells are like bricks that build our bodies, but they're not only bricks, they're very dynamic. So in every cell, there's always constantly a lot of biochemical reactions happening simultaneously. And although these reactions are happening all the time, and there's many of them, everything is always very tightly regulated. And this is what we call a homeostasis, that there is a condition that is very active, but very tightly regulated. And today, from what we know, we consider this endocannabinoid system to be a very strong regulator of this homeostasis. So we can imagine homeostasis as being this very basic balance in our bodies, in our cells, coming from the cell, from the basic unit of life, from the cell on. And we in fact know that when this homeostasis in a cell becomes challenged, let's say that we physically injure ourselves, something happens and we have a very strong emotional reaction, or anything happens in our bodies that causes this homeostatic mechanism to come out of balance, our bodies produce cannabinoids that then activate whatever is necessary for our cells, for our body to return to balance as soon as possible. And this is how we consider this endocannabinoid system to function. And when scientists were studying what everything this endocannabinoid system does, it was very difficult to find a simple answer, because whatever the scientists study, was it the cardiovascular system, was it the brain, was it the gut, or the muscles, cannabinoids had a very strong impact or influence on this bodily system. And now, after much research, we say that the best way that we can imagine what the endocannabinoid system does in our body is to imagine the 5, let's say, very important or primal areas in our life, meaning that they regulate our appetite, that they regulate our sleep, and not only do we sleep well or not, but the entire 24-hour cycle, the circadian rhythm, is very tightly regulated by the endocannabinoid system. And then also our ability to relax, but also not only the relaxation itself, but also how well we are able to use our muscles for all our daily activities and for everything we want to do. And on the other hand, how well is our body, our muscles, capable of relaxing when we don't need this tension. And then, of course, memory and on the other side, forgetting are very strongly regulated by the endocannabinoid system. This was especially interesting that scientists figure out that actually cannabinoids in many cases cause us to forget. We also know this from people that get high, that they have these gaps in their memories. And it was interesting to see why it was important for people to forget certain unimportant things. And the patients with PTSD, so post-traumatic stress syndrome, showed this very clearly, that if we are not able to forget events, information, and things that would be good for us to forget, what kind of an effect this on the long term can have. So the effects of cannabinoids, that they actually cause some form of healthy forgetting, seems to be very crucial. And then the fifth area is we can imagine that as a general protection, meaning, for example, our immune system, how well we are resistant to common colds that are happening around. And so we can imagine this endocannabinoid system to be like a guardian of our own inner homeostasis. And so it happens from the level of cells, tissues, bodily systems, even emotions, and generally how well we're able to cope with life and its challenges. And the way in a very healthy body, we produce enough cannabinoids that we are able to sustain this homeostasis on our own. But on the other hand, living in a modern society that comes with many, many challenges, from environmental toxins to time limits, to constant deadlines, to poor sleep, to many, many more stressors that our bodies are used to, this homeostasis can come out of balance. And we know today that for vast majority of chronic illnesses, the first step necessary for a chronic illness to be able to develop is exactly this, that this homeostasis is no longer, it doesn't sustain anymore. So the endocannabinoid system is not capable of maintaining homeostasis, and chronic illnesses have like a path where they can develop. And this is where cannabinoids that we can bring into our bodies from outside, preferably from a plant, become very important, because they can take over this guardian role of cannabinoids that in ideal case our bodies would make themselves. And if we come to the skin part, we know that every part of our body has cannabinoid receptors, and every part of our body produces their own endocannabinoids. And the same is also true for skin. We know that the endocannabinoid system is very strongly present, all of its elements in the skin, in all of the layers of the skin. And we know that the dysregulation of this very important endocannabinoid system is implicated in several skin diseases that are also very prevalent. For example, this dysregulation is very well described in atopic dermatitis, in psoriasis, in scleroderma, also in acne and other inflammatory conditions in the skin. Also, we know that in the hair follicles, so in hair growth, lack of it or too much of it, also cannabinoids play a very important role, and also in pigmentation or dyspigmentation disorders. Also, tumors in the skin and excessive itching are known to be strongly related to this dysregulation of this endocannabinoid system that we have in our skin. And now if we imagine, so this would be the anandamide and 2-AG are the cannabinoids that our bodies make themselves. So this is a typical case of an endocannabinoid. And then if we look at the plant analogs, so THC would be an analog to anandamide, and CBD would be an analog in function to 2-AG. And if we look at the chemical formulas, they don't look very closely related, but nonetheless, they are able, these two are able to perform very similar effects in our body. And the reason for it is because everything in our bodies, in our life, is three-dimensional, and there's a part of the molecule that is very similar and can bind to the same receptors on our cell hence producing the same function. And now if we come to, in the last years, the most well-researched cannabinoid, this is the cannabidiol or CBD. And we know already that CBD has a very large spectrum of effects and a very large spectrum of positive effects. It was very well researched as an anti-epileptic. We know that it has very good anti-anxiety and antidepressive effects because it regulates the production of neurotransmitters in our body. These two effects are maybe not so important when we talk about skin, but if we look at the anti-inflammatory, antioxidant, and other effects of the CBD, we can very clearly and very fast see that it has very high potential also for skincare or, treating different conditions in the skin. Now, cannabinoids exist in two forms. So cannabidiol is the carboxylated form. So we have an acid form, and when this acid form loses a CO2 group, that usually happens when we heat up this acid form. And both of these two, so CBDA or the acid form is usually found in the fresh plants. And also this form has been found to be to have a different but also very potent effects that are important for skin. And it's very interesting also to consider a combination of these two molecules, because CBD is fat soluble, so it can penetrate layers of the skin that have more fat content, and the CBDA is water soluble, so it can penetrate to layers that have more water, that consist of more water. So it's also very important to combine different cannabinoids to achieve really good effects. Now, if we look at the plant is one of the most diverse plants in terms of chemistry. So the cannabis plant has been found to contain more than 1,000 biologically active ingredients. Out of them, about 144 cannabinoids, 160 different terpenes, and so forth. So when we talk about the potential that a hemp or cannabis plant has in cosmetics and for health and well-being, for anti-aging effects, it's important that we understand that we're never talking about just a single molecule, but that we're talking about a bouquet of bioactive compounds. And the best way to use them is always to use full plant extracts and to use them because they have a synergistic effect that in the cannabis world we call the entourage effect. So this is the synergism of all of these different 1,000+ molecules that we bring. So when we talk about CBD, which is very popular in the last years, we're only talking about the tip of the iceberg. But in reality, we have to be aware that all of these terpenes and the cannabinoids, they all contribute effects that in the end produce what we want and really bring the body closer to its homeostasis. And this can happen either in the skin or when we ingest them, it happens very systemically in our body, that these molecules actually, let's say, support or reestablish our basic biochemical balance. And this is the reason why these molecules are so extremely potent. Now, here are just a few examples of cosmetics that are already on the market that contain cannabinoids. They range from tooth care, they range from shampoos, creams, serums, all possible. And my perspective, this is my, now, let's say, my closing thought. Now, one thing is to talk about cannabinoids as skincare products, where already here in this respect they have humongous potential. But my perspective for these molecules is actually much broader, because we can talk about aging in terms of what we see in, I don't know, wrinkles or saggy skin, but actually what we see on the outside is a consequence of the age we carry inside. So our biological age, how, in what kind of a condition or age our organs and our body as a whole is. And here cannabinoids can play a very, very vital role in their anti-inflammatory effects, we know that they prevent the telomerases from becoming shorter, which is very important for aging. So they have many, many mechanisms how these cannabinoids can help sustain our inner well-being biochemically and also emotionally. And here I think that if we take good care of how our organs and our whole body is feeling, how our cell as a basic unit is functioning, then we can also hope for a much better skin and youth on the outside. So this would be my closing thought, and thank you very much.